Hello. Now we'll see the question from GATE 2014 ECE from the signals and system subject. So here let x of t equals to cos 10 pi t plus cos 30 pi t be sampled at 20 Hz and reconstructed using an ideal low pass filter with cutoff frequency of 20 Hz. The frequencies present in the reconstructed signal are. So here given the continuous time signal x of t and that is sampled with a sampling rate of 20 Hz. So given that, coming to the solution, given that x of t equals to cos 10 pi t plus cos 30 pi t and fs equals to 20 Hz is given, and reconstructing using an ideal low pass filter with a cutoff frequency of fc equals to 20 Hz only given. Now we can observe that by finding the maximum message frequency here, that is equals to omega max equals to 30 pi here. So from this we'll get f max equals to 15 Hz. So f max equals to 15 Hz. So by observing the Fourier transform of the sampled signal here, by observing the Fourier transform of the sampled signal, so Fourier transform of sampled signal is considered as, let us consider this is like xs of omega. So this is the frequency fs equals to 0, and this is the message signal having the value of 15 Hz here. So it is minus 15 and this is 15, and we have one more frequency component at 20, that is the sampling frequency fs at sampling frequency fs. I'm drawing only the Fourier transform of the sample signal as we already know. So fs equals to 20 Hz is given, that's what I indicated here. So at 20 we have the same frequency components with a width of minus 15 one side 15 one fs minus f max and fs plus f max. So fs minus f max means 20 minus 15 is nothing but 5. So we have a component at 5 here, and we have the another component at up to this 20 plus 15, that is 35. And coming to this side we have at minus 20, we have at minus 20. So this is minus fs plus fm, nothing but minus 20 plus 15. So we'll have the component at minus 5, minus 20 plus 15, and we have another one minus 20 minus 15 minus 35. So that's what the frequency components of the sampled signal. Now in order to reconstruct the original signal, here they use the ideal low pass filter with a cutoff frequency of 20 Hz. So here they used the ideal low pass filter, with a cutoff frequency of 20 Hz. So here we can observe that this is having the magnitude spectrum like this. This is having the magnitude spectrum from ideal low pass filter taking on the both the sides. So this is the magnitude spectrum of the ideal low pass filter. So they asked only for the positive side, they given only the positive side frequencies. So you can observe that this low pass filter can pass the frequency components at 5 and 15, and also at minus 5 and minus 15. So this is an ideal low pass filter having cutoff frequency of 20 Hz. That's why it can pass the frequency components at 5 and 15 Hz. So we don't have any frequency component at 10 Hz. We don't have any frequency component at 10 Hz. So it can pass the frequency components of 5 Hz and 15 Hz, not the 10 Hz. So we can take the option A is the correct answer from this. So it can pass only the components of 5 Hz and 15 Hz.